I'm Anil Kumar. Welcome to my series on set theory. Now, let us have a small quiz where we will see how to write sets in Rooster form and in set builder form. So we have 4 examples here to work with. So I'd like you to pause the video, copy these questions, answer, and then look into my suggestions. So in the first case, we are given a set in Rooster form A equals to 0, 3, 9, 27 up to 63. You need to provide this set in set builder form. Set B is B where B equals to 2x plus 1, x is greater than equal to 1, less than equal to 5, and x belongs to set of natural numbers. You have to write this in Rooster form. C. Set C is such that C equals to 1 plus x squared, where x is less than 5, C and x belongs to natural numbers. You have to list all the elements of this set. Now we are given the elements of set D as minus 3, minus 1, 1, 3 and 5, and we need to write this in the set builder form. So that is the exercise. You can pause the video, answer, and then look into my suggestions. Now here, what we notice is that the set A is equal to the elements which are product of 3, right? So 3 times 0, 3 times 1, 3 times 2, 3 times 3, and that is 3 times 21, right? So that is how we get all the elements mentioned in set A. So we could define this as set of A. So A becomes the variables so that A belongs to, we can write A equal to also product of 3 with n, right? So we can say 3n, right? Where we can define what n is, right? So n becomes a whole number less than 21. So we can say n is less than equal to 21 and n belongs to whole numbers. So that way the set has been clearly defined. See, in this particular case, we did not write what A is. We wrote A indirectly, that it is a whole number, product by 3, right? Okay, set B. Set B, we need to list all the elements from the properties given. B equals to 2x plus 1, where x is greater than equal to 1. That means 1 is included and 5 is also included. All natural numbers 1 to 5. If I substitute 1 here, 2 times 1 is 2, 2 plus 1 is 3. So we get first element as 3. For x equals to 2, we get 4 plus 1 as 5. For 3, we get 7. For 4, we get 9. And for 5, we get 11. So we get these 5 elements for set B. Note, we have to include both 1 and 5 since it is greater than equal to, right? And less than equal to 5. In set C, C is such that C equals to 1 plus x squared, x is less than 5, C and x both belong to natural numbers. Now here, we have only seen inequality of the form x less than 5, natural numbers. That means 1 to 4, right? So for the values of x as 1 to 4, we need to find what C is and then get our set. So that is how we are going to list all the elements. For x equals to 1, 1 square is 1, 1 plus 1 is 2. For x equals to 2, 2 square, 4, 4 plus 1 is 5. 3 square is 9, 9 plus 1 is 10, 4 square is 16, plus 1 gives us 17. Should I take 5? No, because x is less than 5. Okay. The last one here is set D, where 5 elements are mentioned, minus 3, minus 1, 1, 3 and 5. To get the result, we can see the kind of trend. So from minus 3 to get minus 1, we need to add 2 and then again add 2, and this process is repeated, right? So to get all the 4 elements. So we can now define D as D so that D is equal to what? So we have to derive an algebraic expression to get the result. So it could be written as 2 times some number. So if I do 2 times 1, what do I get? I get 2. How do I get minus 3? Well, if I write 2 times, let's say x. So for x equals to 1, I get 2. How do I get minus 3? So I have to take away 5. So that should give me minus 3. Now let me check. If I put x as 2, so I get 2 times 2 as 4. 4 minus 5 is minus 1. It works. And if I substitute 3 here, in that case 6 minus 5 is plus 1. 4 will give us 8 minus 5 as 3, and 9 will give us 5. So it works. Perfect. So that is how we could define it. So where x is between, we can say, if we are taking x as a natural number, we can say x is less than equal to 1, 2, 3, 4, 5. Less than equal to, and x belongs to set of natural numbers. Does make sense? So that is how we can actually write the given form in set builder form. So in this exercise you have learned how easy it is to represent the sets in either Rooster form, also mentioned as list form, and set builder form. Remember, in the Rooster form we always mention all the elements. In the set builder form we have to build the set from the given condition. Perfect. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Share my videos with your friends. Thank you and all the best.